Hello, class. I'm Ujuak Aleton, your facilitator for Bio 216. We are about to start Module 2, Chemistry of Lipids. Remember, the course is Chemistry of Carbohydrates, Lipids, and Nucleic Acids. We'll start by looking at fatty acids, which is the component of most lipids. I know that when you watch this video, you will have more understanding of what we have discussed in class. Thank you. So, like I said, Module 2, lipids, chemistry of. So, what are lipids? When you want to define lipids, the only definition we can use to encompass all of them is that they are insoluble in water but soluble in organic solvents. When we try to define carbohydrates, we used the presence of polyhydroxy groups to define them, of aldehyde and ketones. But for lipids, you cannot use that for all the lipids. So the best definition and the most encompassing is to say that they are a group of compounds insoluble in water but soluble in organic solvents. The most abundant type of lipid is the triglyceride or the triacylglycerol. Types of fatty acids. Explain the structure and nomenclature of fatty acids. Explain the properties of fatty acids and then the reaction of. Let's look at the composition of lipids. Most of lipids have fatty acids as their building blocks. Please note the word most, because not all lipids have fatty acids as their building blocks. And what are fatty acids? Fatty acids are long chain organic acids, and they have carbon atoms between 4 and 36. They have a single carboxyl group. That's the COH group, just one. And they have that long non-polar tail, which is responsible for the insolubility in water, and is also responsible for the oily or greasy nature. So now look at the structure of the fatty acid. In class, I was trying to explain to you that every fatty acid has a long hydrocarbon chain. You can see it. Then the carboxylic acid, the COOH, you see C attached to O, then this is the carboxylic acid. You see it in any organic acid. So we say that this carboxylic group side is the hydrophilic end and the hydrocarbon side is the hydrophobic end. So we have three major types of fatty acids. We have the saturated fatty acids, the monounsaturated fatty acid, and the polyunsaturated fatty acid. Somebody asks, why is it saturated? What makes it saturated? And the best explanation I had to give was this. All the carbons are bound by 4 atoms. You can see the first carbon is bound by 3 atoms of hydrogen and 1 carbon. So all the carbon atoms are filled, they have something attached to them, so we say they are saturated. They have all eaten, so they are saturated. That is what makes that fatty acid saturated. You see the second one, it is bound by one, a hydrogen, another hydrogen, a carbon on this side, and a carbon on the other side. So it is saturated. It has all the um, four external electrons of carbon have been filled up, have been involved in the electron and in the bonding. So you say it is saturated. The mono unsaturated has one double bond. Mono unsaturated, because it is only one unsaturated bond, one double bond. It says mono unsaturated. You can see the double bond there. You can see that the carbon does not have four of it. It doesn't have four atoms bound to it. It only has one, two, and another carbon. So it has three atoms bound to it. So it says it is unsaturated. It's still hungry. It's looking for something else. Then for polyunsaturated fatty acid, they have more than one double bond. It could be two, three, even up to six, depending on the fatty acid. So now let's look at naming of fatty acid. That's the meaning of nomenclature. When you are naming a fatty acid, you must consider three things. First, how many carbon atoms are in that fatty acid? Does it have a double bond? And what is the position of the double bond? Those are the three major things you will consider. Others will come later. So now we'll look at the one with this fatty acid known as palmitic acid. Of course, you can see from the name, you know it is found majorly in palm fruit or palm oil. So you can see it's palmitic fatty acid. If we need to name this acid, we have to consider the number of carbon atoms. And from what we can see, it has 16 carbon atoms in it. 16 carbon atoms. And then it is saturated because there's no indication that it has a double bond. So now we'll see how we can name it. Because it has 16 carbon atoms in it, we call it hexadecanoic acid. What makes it hexadecanoic? There are two words I have joined together there, hexa and deca. From your maths, you know that deca means 10. When you talked about polygons in mathematics, decagon means 10. A polygon with 10 sides. So this one is hexadeca. That means it has 10 plus 6. 6 means, hexa means 6. So 10 plus 6 carbon atoms. In other words, it's telling us that it has 16 carbon atoms on it. So this fatty acid is a saturated fatty acid. Because it is saturated, we put N normal, N-hexadecanoic acid. The next one we have here is 16. Oh, before we look at that, we see that this one is 16 colon 0, meaning that there is no unsaturated fatty acid. 12 colon 0, this one N-do-decanoic acid, do for 2. So deca, 6 plus 2, N-tetradecanoic acid. Tetra for 4, then 10. 10 plus 4, tetra, 14 carbon atoms with 0 unsaturated bond. But this one is 16 colon 1 delta 9. What are we speaking there? It has 16 carbon atoms and 1 unsaturated bond at position 9, between 9 and 10 in fact. So that's what I have tried to show you. So you call it, for this one, we'll call it 6,9 hexa. I hope you can see the dash there. 6-9 hexa decanoic acid. We are no longer dealing with deca. Now it's enoic. If you can remember from alkenes, now we are telling you that it has double bonds. This one had no double bond. That was why they were deca. This one is the hexadenoic acid. You can see the next one we have 18 colon 2 delta 9 12. In other words, we are telling you that this is a fatty acid with 18 carbon atoms with 2 double bonds, one at position 9, that's between 9 and 10, and the other at position 12, that's between 12 and 13, to give you 6, 6, 9, 12 octa the di, because they are 2 double bond enoic acids. Now, I've added something to the nomenclature which I did not mention before. Cis. You can see cis here and see cis here. This is another thing you consider, especially when you are naming fatty acids that are unsaturated. There are 2 types of arrangement of fatty acids. In other words, you can say 2 types of isomers of fatty acids. One is the cis isomer, the other one is the trans isomer. Draw the structure and give the systemic name of the fatty acids having 18 carbon atoms and 2 double bonds. So you are going to draw it now. I'll give you a few seconds to draw it and then we'll continue. Melting point decreases as the number of double bond increases because there will be more bends. You have you have iron rod, for example, that is straight. You can easily arrange them in a straight form. Whereas if they are bent, they will not be straight. And because they are not straight, the molecules cannot come together. They form oil. That's what happens to fatty acids too. And then the next are the fatty acids also react with the carboxyl group of fatty acids react with the hydroxyl group of some compounds, example glycerol. And when this happens, they form ester. This picture we have here is the picture of glycerol. You must have heard it. Some people call it, at times you call it glycerin. Some women add it to their cream. It moisturizes the body. All these hand sanitizers you see, they'll tell you 70% alcohol. If it's only alcohol you have in it, when you use it to clean your hand will be so hard. So they add glycerin to it. You can call it glycerol or glycerin. So it's still the same thing. So that glycerin reacts with fatty acids to form this OH of glycerin, reacts with the carboxyl group of fatty acid. And when that happens, you have fat molecules. So if one OH of glycerin reacts with one fatty acid chain, you have a monoglyceride. If these two OH groups of glycerin react with two fatty acid chains, you have a diglyceride. Then when three, that's this OH group reacts with one fatty acid, this reacts with another, this with another molecule of fatty acid, you now have a triglyceride. So that is how fat is formed. Remember when we defined fatty acid, we mentioned in our first slide, we mentioned something about triacyl glycerol or glyceride. So that is how it comes. When fatty acid, when the carboxyl group on fatty acid reacts with the OH group of glycerol, you form glycerol. So this is it. You see, when this, you can see the OH group of this long fatty acid chain reacting with the the carboxyl group of the long fatty acid reacting with the OH of fatty acid. This is an ester. So it is, when this happens, if it's only one that has reacted, it is monoglyceride, 2 diglyceride, 3 is triglyceride, or what is called neutral fat. So this is how we have fat when glycerol reacts with the fatty acids. I forgot to mention to you that fatty acids do not usually stand alone in organisms. You cannot see, oh, this is, you check your body, you see one fatty acid. No, they always occur in combination with things. For example, if it occurs with glyceride, it becomes if it occurs with glycerol, it becomes glyceride. It can be mono, di, tri. At times it can occur with phospholipids. At times it can occur with cholesterol. When this happens, you have when it occurs with phosphate, you have phospholipids. When it occurs with cholesterol, you have cholesterol ester. So fatty acid normally will not occur alone. It occurs with something. Let's look at another class activity. Pick the fatty acid that will be waxy at room temperature. Is it lauric acid or palmitoleic acid? Which one will be waxy at room temperature? For you to answer this question, you first of all have to ask, what is the systemic name of this lauric acid? If we know the systemic name, then we can know systemic name. It has 12 carbons. This one, palmitoleic acid, this one has 16. From, if you find out, if you know the systemic name, you find out that this lauric acid is a saturated fatty acid, whereas this one is an unsaturated one. So which one will be waxy in nature? At room temperature, sorry. So find the answer to that. So at the end of this class, we have been able to note that fatty acids are the building blocks of majority of lipids, and they can either be saturated or unsaturated. We have also learned that when we now have to name fatty acids, we name them according to the number of atoms, then according to the their double bond or single bond, depending on what they have. Then we have found that the physical property of fatty acid, which includes their differential solubility, melting points, are determined by the chain and degree of unsaturation. And finally, the fatty acids have the ability to form an ester linkage when they react with some compounds. Thank you.